All right, many of you missed today's class due to the New York City trip and or being sick, so I am making you a video, hopefully to get you caught up. So we nailed down Chapter 2 Table of Contents and tab and started with 2.1 Transformation of Functions. The good news is that much of this is review from the first chapter. So let's take a look at a few features of this particular lesson. All right, so we're going to talk about symmetry in this lesson. And as you know, symmetry is a line that divides something into two equal halves. It can be seen in nature, geometry, letters, even our physical bodies have a line of symmetry, and things such as vehicles. So lines of symmetry are basically everywhere. You just have anything that can be cut into two equal parts has a line of symmetry. This figure in and of itself can be cut into two equal parts as well. This line right here is the axis of symmetry. This is known as a quadratic function, but it also has another name that I'll share with you here shortly in a minute. But the parent function for quadratics is f of x equals x squared. And you'll notice that it's very basic. There's not anything added to it. You don't see any numbers. There's assumed ones and zeros, but that's about it. And this is known as the parent function. We do, however, have more sophisticated templates that I'll share with you in just one second. One of the things about the DNA of a quadratic function is that its highest power is going to be 2. This is known as the degree, and so the degree of a quadratic function is 2. A more sophisticated template is ax squared plus bx plus c. This is known as the standard form. We'll talk about that in the days to come. But today what we're going to do is we're going to talk about the vertex form. And this template should look slightly familiar because it goes along with our GPS system that we learned about in Chapter 1. We call this graph right here a parabola. So we don't call it a quadratic function, we call it a parabola. And a parabola has an axis of symmetry, as we mentioned earlier, and that line divides the parabola into two equal halves. And I use this little abbreviation, AOS, for axis of symmetry. It also has a vertex, which is the lowest part of the graph. It can also be the highest point of the graph if the graph has been reflected. So these are some of the features of a parabola, and we're going to take a look at today the vertex form. Also, I might want to add here is that the lowest point would be called the minimum, the highest point is called the maximum. And again, that goes along with what we learned in Chapter 1. Okay, great. So you get to hear the star. Do you hear that? That's what I get to hear every day about 3 times. The star train. It's a commuter train that runs from Lebanon into Nashville. And it's pretty good for commuters that are at key points in the city. But yeah, they honk their horn pretty loud. All right, moving on from our commercial break. This is the foldable that we received today, and we're going to talk about the vertex form, which is, again, very familiar to us. It earns its title because the equation actually has the vertex of the parabola embedded in it, and that vertex is going to be located at HK. If you think about the transformations that we've talked about in the past, if the vertex starts at 0, 0 and it moves to certain locations based on this template, then that vertex is going to relocate at HK. So what we're going to do is we're going to take a look at some examples. So here we have a template and we want to know where the vertex is. So first thing we're going to do is we're going to talk about the translations. So it goes to the right 3 and up 5. Well, that happens to be where the vertex winds up. So take a look at this animation here. Here's our general template. If we put in or take out H and K, for this particular template, what is H and what is K? Well, the answer is 3, 5. And that's where the vertex is. So it went over to the right 3 and up 5, and that's exactly where the vertex would be located. So here, our vertex is going to be at -5, -3. And here, our vertex is going to be at -7, and the understood number in the background is a 0. And finally, here, our vertex, the number with x is 0, so it's going to be at 0, 8. All right. The axis of symmetry is that line that divides the parabola into 2 equal parts, and it shares a little bit of real estate with the vertex. So whatever the value of x is in the vertex, that's going to be the equation for the axis of symmetry. So let's take a look at those same examples. So whatever the vertex is, you're going to take and you're going to plug it into this template. So let's take a look at how that looks. So here's the generic form. If we take out all the players here, the axis of symmetry is going to be x equals h. Well, in this case, h is equal to 3. And so that's your axis of symmetry. The thing about this here, folks, is that most people leave off this part right here. Oftentimes I just see a number as the axis of symmetry, and you have to write it as an equation of a line, which is x equals h, or a certain number. Okay, so in this next one, the certain number is -5. In this case, the certain number is -7. And in this case, the certain number is 0. All right, on to our last, nope, I'm sorry, I take that back. We have a little example. Find the axis of symmetry of the parabola shown. So the first thing you need to do is locate the vertex. It's right there, and that is 2, 1. So let's just hone in on the x value. That's going to be the same exact number as the axis of symmetry. So it's going to be x equals 2. And that's simply how you do it. And the line looks like this. That's the axis of symmetry. X equals 2. Finally, max or min, the value of a controls the direction and width of the graph. So, as we have noted in the past, if a is positive, the parabola is going to open up. If a is negative, it's going to reflect or be concave down. All right, and so here's those same examples. We're going to inspect what the value of a is. So in this case, the number out in the front is a 1, and so it opens up. In this case, the value of a is -2, so it opens down. In this case, the value of a is 1/4. Since it's positive, it opens up. And in this case, the value of a is 1, and it opens up. Now, when you have a graph that opens up, then the axis of symmetry, or I should say the vertex, is going to be the minimum point, the lowest point on the graph. And in like manner, when you have a graph that opens down, then that highest point is the max. All right. And we did several of these in class. I'm just going to show you the answers to this. You can look at it and make sure you understand. Whoops, I thought I was going to do that. I guess I only did the first one. So you can see from these examples that you have 3 distinct answers. You have the vertex, the axis of symmetry, and whether the graph opens up or down. And that concludes this video. I hope it was helpful. You may need to rewind and replay because I think I spoke like 90 miles an hour. At least that's how I feel. So again, you might need to go back and just maybe slow it down a little bit. Hope this was helpful. See me in class if you need any extra explanations.